Hello everyone, my name is K. Ranjit Kumar. Today we are discussing about a very most fundamental topic in switching theory and logic design subject. Here the topic is binary number system and conversions. Let's start with some basics. A binary system is a number system with base 2. It means the binary system is a base 2 number system. In this, we can use only the numbers 0 and 1. These 0 and 1 are called as bits. This binary system is widely used in computers and digital systems. Why? Because it aligns perfectly with the two-state nature of electronic circuits on and off. First, we will convert a decimal number to binary system. How do we convert a decimal number into binary system is we can convert a decimal number into binary by dividing the decimal number with 2. Then we have to write all the reminders respectively. And then we have to repeat this process until the coefficient will become 0. Then the binary number is reverse of your reminders. First, we can take number 13. It was converted as binary like 1101. Here is the process. We can see how the number 13 is converted into binary. And then we will see from binary to decimal conversion. Multiply each bit of your binary number by 2. Raise it to its position power and we have to add all that. For example, we can see the binary number 1101 is converted into decimal number 13. Here is the process. We can see the 1101 how it was converted into decimal number 13. Now we will convert a binary number into octal and then we will convert an octal number into binary. To convert a binary number into octal, we have to group binary digits into group of 3 bits in a binary digit. Binary digit from the right in your binary digit. And then we have to convert that group of 3 bit into a octal digit using 421 code. Here is the example for conversion of binary to octal. Here we can see 110 and 101. We have to divide this 6-digit code into two parts, 110 and 101. And we have to use 421 code and we can convert into octal easily. Now we will see the conversion from octal to binary. It is a simple process. We can simply replace each octal digit with its 3-bit binary digit using 421 code. Here is the example for converting a octal number into binary number. Now we will see the conversion from binary to hexadecimal and then we will see hexadecimal to binary. As like in the binary to octal, here also we have to group the 4 bits, group of 4 bits in the given binary code. And we have to convert that 4-bit group into that hexadecimal number using 8421 code. For hexadecimal, there are the numbers from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, E until E. Here we replaced 10 into A and 11 for B, 12 for C, 13 for D, as like is this 15 for F. Now we will see the conversion from hexadecimal to binary system. Here also the same process. We have to convert the hexadecimal digit into the 4-bit binary code using 8421 code. And here is the example for the conversion from binary to hexadecimal, and this is the example for the conversion from hexadecimal to binary. Here in the binary to hexadecimal example, 110 and 10111 is converted into hexadecimal as like this D716, and this D716 is converted into this 11010111. Now we will convert the octal number into decimal number, and then later we will convert the decimal number into octal. First we have to convert the octal number to decimal number. Then we have to multiply each digit by 8, raise it to its position, power, and we have to add all that. For example, the 127 base 8 is converted into decimal number 87. This is the process we have to follow to convert octal number to decimal number. Now we will see the conversion from decimal to octal. To convert the decimal to octal, repeated division by 8, and we have to write all the remainders in reverse order as like in the binary to octal. And here is the example. 87 is converted into octal number 127 base 8. Now we will see the conversion from hexadecimal to decimal, and then we will see the conversion from decimal to hexadecimal. First we have to convert hexadecimal to decimal number. We have to multiply each digit by 16, raise it to its position power, and then we have to add that numbers. For example, we can see the 2f16 is converted into decimal number. This is how the hexadecimal number is converted into a decimal number. We have to, here the 2f16 is converted as 2 into 16 power 1 plus 15 into 16 power 0. Here the f equivalent number is 15, so we can take as 15. Then the 2f base 16 is converted as 47 decimal number. And we have to convert that decimal number into hexadecimal. We have to divide by 16, and we have to write all the remainders respectively, and then we have to continue this process until the coefficient becomes 0, and then the decimal number is and the hexadecimal number is 2f16. Here is the example for conversion from decimal to 2f16. Here f stands for 15. 47 is converted into decimal number. Now we will see the conversions of octal to hexadecimal, and then later we will see the conversion from hexadecimal to octal. If we want to convert an octal number into hexadecimal, first we have to convert that octal number into binary, and then that binary number can be converted into hexadecimal. So here is the example for conversion of octal number to hexadecimal. 157 base 8. The binary number is for 157 base 8 is 001 and 101111. It is the code which is written by using the 421 code, and the group of all these numbers can be written in binary, and that binary number can be converted into a hexadecimal number. We have to use the same procedure for conversion for hexadecimal to octal. First, we have to convert that hexadecimal number into binary, and that binary number can be converted into octal. Here is the example for conversion of octal to hexadecimal. The 6f16 is converted into 0 1 1 0 1 1 1. This binary digit is taken by using the 8421 code, and it is the group of 4 bits, and we can group this all the binary digits, and we have to group of 3 bits, and then the 6 of 16 can be converted into 157 base 8. This is the process we have to use from for conversion of hexadecimal to octal. Here is the summary of all conversions. Uh, Let me summarize. If we want to convert a decimal number into binary, we have to divide or multiply by 2. It means if we want to convert decimal number into binary, we have to divide by 2. And if we want to convert a binary number into decimal number, we have to multiply with 2 with each digit. If we want to convert that binary number into octal number, we have to group with 3 bits. Okay, 3 bits, and we can convert that group of 3 bit into a octal digit. And then if we want to convert that octal digit into binary, we have to group that octal digit in a group of 3 bits, and then we can group all that numbers, binary numbers, into a binary digit. If we want to convert a binary digit into hexadecimal, we have to group of 4 bits in a binary digit, and then we can write the hexadecimal digit using 8421 code. Conclusion: the binary systems forms the foundation for a Google computation. Conversions are essential for understanding how computers handle the data. The mastery of this conversion is critical in fields such as computer science and electronics. Thank you all for your attention.